Let's start with the first example, r equals 2 sine theta. Okay, now here's what I'm going to do. And always I'm going to use these relationships between r, theta, x, and y. So everything that I do is going to somehow connect back to one of these four equations. So for A, we can just look. Now if r is equal to 2 sine theta, I am looking at, let's see here, looking at this equation here. And it'd be lovely to have an r sine theta because then I could replace it with y. So I'm going to multiply both sides of my equation by r and get r squared equals 2r sine theta. Now r squared is x squared plus y squared. And 2r sine theta is 2y. So I have written this equation in terms of rectangular coordinates, right? So I started off with r equals 2 sine theta, and now I've got x squared plus y squared equals 2y. Next, let's go ahead and identify this and graph it. So if we've got x squared plus y squared equals 2y, I can subtract x squared plus y squared minus 2y equals 0. And now it's time to complete the square. So I have y squared minus 2y plus 1 equals 1. And I've got x squared plus y minus 1 squared equals 1. This is the equation of a circle with a center at 0, 1 and a radius of 1. Okay, so this is x. This was kind of a crappy circle, but you get it. So it is a circle, center 0, 1 with a radius of 1. Now, what about b? Let's see here. b is r equals 5. Now, r equals 5, what am I going to do with that? Hey, I know what are the points. What points are satisfied by r equals 5? Anything, 1, 2, 3, 4, 5, any point that is on this circle satisfies r equals 5, right? And if if r comma theta satisfies r equals 5, then that point r comma theta is on the circle. So this is just going to be the circle with a center of the origin and a radius of 5. Okay, so what would we get here? We would get x squared plus y squared equals 25 for our equation. Let's look at C. C is theta equals pi over 4. So for theta equals pi over 4, let's add one below, add a page below. So we've got theta equals pi over 4. Now we've got to think about what are the points that satisfy theta equals pi over 4. I'm going to start off drawing my pole and my polar axis. And I know that I'll have my concentric circles. Even though these are kind of lumpy, you get the idea. And so these are all my values of r. So I've got these concentric circles, right? I can get as much detail as I want, right? Because we could have r equals 1/2, r equals 1/3. Infinitely many circles, right, make up this, just like there are infinitely many lines in the regular rectangular coordinate system. And then I can start putting in this is theta values. This is theta equals pi. This is theta equals pi over 2. So theta equals pi over 4 is anything that is here. So r can be anything. So r is anything. and theta is pi over 4. We want to say, what are the points that are described by this, right? R comma pi over 4. The answer is anything that's in this positive ray. But wait a minute. Since r can be negative, imagine, for instance, if you had 2 comma, if you had negative 2 comma pi over 4, what would that look like? Where would we plot that? We would go out to 2. Let me use a different color here. So we would go out to 2, and then we'd go up to pi over 4, right? And then because it's negative, we would flip it. So any of the points that are down here also belong to our graph, because these represent points where r is a negative number. Okay, so it turns out that theta equals pi over 4 is a line through the origin and in fact, one way to do this, just manipulating those equations, is to say if tangent of theta is equal to y over x, what is tangent of, now theta is always equal to pi over 4, what is tangent of pi over 4? It's equal to 1. That's y over x, so that's the same thing as 1 equals y over x, which is the same as y equals x, which is the equation of a line, right? Another way would be to say, hey, I know what these points are, one, right? This has to be, if this is pi over 4, then this is a line y equals x. Okay, so we've got our equation and our description. And now, didn't we have another? Let's see, what else were we supposed to do? D. Ooh. Okay, this one is looking a little longer. Copy. Paste. Okay, so this is our problem for D. And for this problem, if I've got, here's what I want to do. I just want to replace things, because this r cosine theta, that's the same as y. R sine theta, that's the same as x. And then r squared is just x squared plus y squared. So it looks like I'm going to have a conic section, x squared plus y squared plus 4x minus 8y equals 5. Looks like I'm going to have a conic section. Let's see if I can go ahead and complete the square. X squared plus 4x plus y squared minus 8y equals 5. This looks like it will be an ellipse. So completing the square will leave me with, so it's 4 divided by 2. Okay, so plus 4 plus 4. And now this, divide this by 2 and square it. So I have plus 16 plus 16. Okay, so I've got x plus 2, quantity squared, plus y minus 4, quantity squared, equals 25. Oh, okay, so we've got a cute little ellipse. No, is that an ellipse? No, that's a circle. And it is a circle in the center. Let me switch pens. This is difficult to see. So as we've got a circle, and the center is negative 2 comma 4, and the radius is not 25. I'm just joking. The radius is going to be 5, right? So we go to negative 2, and then up to 4, and then go out 5, so 2, 4, 5, something like that. You get the picture. Okay, let's do E. E is r equals secant theta. Okay, let's see, what can we do with that? So E, r equals secant theta. Oh boy, what is secant theta? Secant theta is 1 over cosine of theta. So if that's equal to r, it looks like we should multiply both sides of our equation by cosine of theta. So then we'll have r cosine theta equals 1. The left-hand side, that's just x. x equals 1. So we know exactly what this graph looks like in rectangular coordinates. It is just a vertical line, right? X equals 1, it's just vertical line. So there's a vertical line. So notice, here's what I want to point out. So notice that simple equations in Cartesian coordinates like x equals 1, y equals 2 are very complicated equations in polar coordinates, right? You've got to use like secant and cosecant, right? So it'd be r equals secant theta, r equals 2 cosecant theta, right? But then on the flip side, what's simple in polar coordinates, simple polar stuff, like theta equals pi over 4, r equals 6, can be complicated Cartesian stuff. Well, so for the theta equals pi over 4, that's not that bad. That's just an equation of a line through the origin. But take a look at r equals 6, which is going to be x squared plus y squared equals 36, you know? So that's pretty complicated compared to just r equals 6. So there are trade-offs, right? And which coordinate system you use is based on and is determined by what you are trying to graph. So if you're trying to graph something that is very boxy, it's best to use Cartesian coordinates, right? Things are boxy. If it's good to approximate it like a box. But if things are, more flowy, circular, it's a great time to use polar coordinates, okay?